Okay, recall this problem from a previous worksheet. The value of an Accord bought new for $25,000 depreciates by 20% each year. If your car costs $8,200, approximately how many years old would you expect it to be? Do y'all remember that problem from last Thursday's worksheet? Hey, did you grade those? Not yet. Okay, now, so we set it up by putting the start value of $25,000. Is this a growth or a decay? Decay. So we had to use 1 minus the rate. Well, what is the rate? So 0.20. And then they want to know how many years. So right now we don't know the time, so we just leave it as x. Now, you could also go ahead and rewrite this as 25,000 times what?
1 minus 0.80.
0.80. Okay, and that's basically saying that your $25,000 car is only worth 80% of its original value, or its previous year's value, because 1 minus 0.20. Okay, now, remember on this worksheet, they told you to figure out the car's value when it was 1 year old. So you would have plugged in 1 for x, and we found out that after 1 year, it's now worth $20,000. And then they asked you to find out how much it was worth after 8 years. And we found out it was like, I forgot the exact number, but 4,000. It was like 4,000 something. So then they said, if your car is worth 8,200, approximately how many years old will we expect it to be? Well, 8,200 is in between these two, correct? So wouldn't your car have to be between 2 and 7 years old? And from there, didn't we just kind of have to plug in 2 through 7 until we found the number that made this, or close to that? And yes, it was about 5 years. When we typed in 5, the value of it was about 8,192. Now, this was not a hard problem because your range wasn't that big. Like, all you had to type in was from 2 to 7 and really only to 5. You didn't have to worry about 6 and 7 because by the time you plugged in 5, you got to your answer. But can't you imagine a scenario where you're going to have to plug in a lot of answers till you find the right one?
Yeah.
Okay, so for that reason, we're going to learn how to rewrite the exponential equation today as a logarithmic equation. Now, the reason we're able to do that is because they're inverses of each other. Okay, and that way you won't have to guess and check. You can go straight to the answer. So let's look at these examples. An exponential equation is in the form y equals b to the x. Remember, sometimes you can write the a, but if there's no a visible, it's an understood 1. So if I write it like this, is that the same thing? Yes, that's the same thing. It doesn't matter which side you put the y on. It's still an exponential equation. Now, the reason that I'm showing you that is because 1 through 4 are all written in that form. b to the x equals y. They want you to rewrite it as a logarithmic form, which is log base b of y equals x. Okay, so obviously when you're rewriting it as a logarithmic function, the first thing you need to write is what? Log. Then you put your base, which is your b value. Look over here, which number's in the b spot? 2. So log base 2 of y, what's the y value? 32 equals the x value. What's the x value in this problem? 5. Look, x, 5. Okay, now watch me type it in to check it. Okay, everybody look. If you type in math and then go to log base, kind of like we did last week when we were graphing these. Okay, look, my base is 2, so it goes in that little box. And then 32, and then equals 5. Well, let's see what it equals when we hit enter. 5. That lets you know that we've rewritten it correctly because it actually makes sense mathematically. So now let's look at number 2. When we're rewriting it into log form, the first thing we write is log. Then you write your base, which is your b value. What's the b value out of these 3? 5. Then you write the y value, which is 125, and then it equals the x value, which is 3. And then couldn't you type that in and check it to make sure it does equal 3? Yes, Alex? Okay, number 3, log base, what is the b value? 2 of equals, so that's not one that we're going to be able to type in because we have two variables, and so you can't type that in. Okay, number 4, log base 7 of equals. Okay, does everybody feel comfortable with rewriting an exponential to a log? And everybody feels comfortable with how to type it into check and make sure you rewrite it correctly? Okay, let me show you something else. Look at the board. See how the 2 is first, the 5 is first, the 2 is first, and the 7 is first? Like if you're looking at it like this is the first number, second number, third number. Then this would be the first number of each one, right? Well look, didn't it remain in the first place? 2, 5, 2, 7. It just dropped down as the base, so it dropped down to subscript. And then look at the x and the y. The 5 and the 32, what happened to them? They just switched sides. The 32 came over here to the left side. The 5 went over there to the right side. Didn't that happen for every problem? The x and the y just flip-flop? So that's just a pattern that you can see to make it easier. Okay, now turn to the next page. Number 1, we're going to rewrite this from exponential to logarithmic form. So what's the first thing I write? Log. What is the base? 2 of equals 3. Okay, all you do is the first number stays first. It just drops down to become your base. These two numbers just switch sides. The 8 comes over here, the 3 comes over here. What can we do in the calculator to make sure we rewrote it in the correct form? Right, just plug in log base 2 of 8, and when you hit enter, your calculator should say 3. Okay, number 2, log base of equals 4. Okay, I'm going to give you about a minute to try through these. For this one, log base 4 of 64 equals 3. Is that what you got? Okay, number 4, log base 5 of 625 equals 4. Number 5, log 10,000 equals 4. Do you have to when it's a 10? No, it's an understood 10. Now, if you want to, you can write it in if it makes you feel better. But when there's no visible base, it's understood to be a 10. Okay, number 6, log base 2 of 1 over 8 equals negative 3. Log base 27 of 9 equals 2/3. And log base 16 of 8 equals 3/4. Okay, so does everybody feel comfortable changing it from an exponential to a logarithmic form? Okay, now let's go back to page 17, and now we're going to rewrite it the other way. We're going to go from log form to exponential. So currently it looks like this. Log base b of y equals x. And we want it to be in the form b to the x equals y. So our b comes first in this form. What is our b? 2. And then look, x equals y. Don't we want it y equals x? So don't we just basically flip-flop these two? But when you do, the 3 becomes an exponent. And that makes sense because when you look at that, in 2 cubed 8. Okay, so for number 6, what number comes first? What's the exponent? 3 equals, and doesn't that make sense? Isn't 6 times 6 times 6, 216? Okay, number 7, what's the base? To the, right, and so that one you can't really check. Okay, number 8, what's the base? 10. There's an understood 10 right there. And what do we do to it? Cube it, and you get 1,000. Okay, now look, several times today, and I understand why, but people want to write a 1 right there. Okay? But think about it. If you write a 1 right there instead of a 10, you would end up with 1 cubed equals 1,000. Is 1 cubed 1,000? No. So that would have been your indicator that something's not right, because 1 cubed does not equal 1,000. 10 cubed does. Okay, now turn to the next page and let's practice these. Okay, so for number 1, what would it look like? Right. Okay, what about number 2? 3 to the negative 3 equals, why does that equal 1 over 27? Right, because remember, to make a negative exponent a positive one, Don't you have to throw it up under a 1? And what is 3 cubed? 27. That's how they got that 1 over 27. Okay, take a minute and do 3 through 10. That's what you should have got. Go and check your answers quickly because I'm about to flip to the next page. Okay, here we go. Now, the whole reason that we learned how to rewrite them is so we can solve. Like when you're given an equation with an x and they say solve, aren't you trying to isolate the x? Isn't that the whole goal, is to isolate the x, get it by itself? Well, watch. If we take this and rewrite it as an exponential, won't it become 2 to the 6th power equals x? Didn't we just get x by itself? Now all we have to do is simplify. What is 2 to the 6th power? 64. And so then you solve the problem. Now, you can check your work. How do you think you would check that? Okay, plug it in how? If you pull up the log base, and then look, you plug in the 2 into the base, what would you plug in the parentheses? X, which we're saying is 64. And if we're right, what should the calculator give us? A 6. And we're right. Okay, example 2. What do you think we need to do first? Okay, look at this 2 in front. Isn't that 2 being multiplied by the log? So how are you going to undo it? Divide by 2. So now I have log base 3 of 2x equals 1. Now when I rewrite it, what will that look like once I've rewritten it? 3 to the 1st power equals 2x. Well, what is 3 to the 1st power? We did. We divided to get it over here. 2 divided by 2 is 1. Oh, did I mess up? Oh, no. Okay, now I did. Okay, if you go back, I just rewrote it first. Log base 3 of 2x equals 1. Now I'm ready to change it over to exponential by doing 3 to the 1st power equals 2x. See, at this point I moved it over. Now to get x by itself, don't I just divide by the 2? And so x equals 1.5. 3 over 2 is 1.5. You go to math and then all the way down to log base. Okay, for example 3, what is the base? 10. Okay, so when I rewrite it into exponential form, what will it look like? What will go 10 to the? Correct. Okay, look. Log base b of y equals x. The base is 10. Y is all of that. And then x is 5. So when I rearrange it into b to the x equals y, that's what it looks like. So now I need to actually evaluate. Well, first, don't I need to kind of do 10 to the 5th? What is 10 to the 5th power? 100,000. And now what do I do next? Correct. Subtract the 1. And what is 100,000 minus 1? 99,999. And now to get x by itself, what's the final step? Divide by 3. What's 99,999 divided by 3? I'm going to write it up here because I've run out of room. 33,333. You could even check that one. You would type in log. Okay, let me show you. For this one, what's the base? What's the base of this? 10. So you don't have to use the log base. If you just hit log, that's understood base 10. You don't have to go into the math log base. Now watch. 3 times x. What is our x? 33,333 plus 1, and then equals 5. Isn't that what it says it equals? That's how we know we did it right. Okay, your homework is 1 through 10. Okay, it doesn't require a calculator because once you rewrite it, any calculator can do these. Okay, so your homework is 1 through 10.